Yes, ma'am. Okay, so with this is Foundations of Derivatives Part 3 per se, but what we're going to talk about today is we're going to make sure we understand how to draw that derivative and how to draw that next derivative. So that's going to be hopefully what we do in this 15 minutes, but it probably won't happen in 15, it'll probably happen in 30. Okay? So, right away, I need to know where my pins are. Okay, and then to go from there, I have to know a few things. One, y is equal to f of x. I have to know that. I have to understand that backwards and forwards. F of x equals y equals f of x. Okay, for the same aspect, okay, I have to know that the derivative that we talked about last week was the change, this triangle is the change in y over the change in x is equal to what we call dy dx, or y prime, or f prime of x. Okay? These are all the same thing. Now obviously, we don't do this and this very often because when we start talking about double derivatives and triple derivatives, quadruple derivatives, this doesn't work for us. For a derivative, these both work just fine. But when we start talking about doubles and triples, this doesn't work and we need to switch to this. And the reason why we talk usually like this is because we're talking about functions. But you'll see it both ways in the book. And the reason you see it both ways is you can't write the function with, just the function with respect to x equals something like 1 over x minus 2. Just something that simple. Because that's not a function. Okay? So we can't do that. Okay? Another one, a real simple one, x squared minus y squared. We can't do that. Because that's not a function. That's a circle. So there's, remember the whole function rule? As soon as things start going like this, right? So when do they go like that? And that's when f of x, or y equals x squared, becomes this. Y squared equals x. Okay, now when y squared equals x, how do I solve that? I take the square root of the square root. Uh-oh. That way, x is equal to the square root of x. Uh-oh, that's not a function. That's why we write it as y equals. Okay? So that we can still go y prime of x. But we can't say what's the function with respect to x. It's not a function. Okay? So that's why it's kind of confusing. But it's also why we use those multiple languages, right? Why these are all the same thing, but we use them for different things. Okay? We use this to discuss the change in y over the change in x. Why? Because this came from our very first thing back in 99, which is y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Or in other words, the slope. Okay? This is just the slope, and that's what we're talking about in the function, the slope. If you remember in our last talk, last week, I kept talking about how it changed right here. And then, oh, what's a real important change here? Oh, when it hit 0, right? So then when would be the next important change? Right here. And then the next one, right there. And then the next one, right here. Okay? And the next one, right here, the next one right here, and this doesn't go straight down. It's good to know that that doesn't go straight down. It's important to know it doesn't go straight down. It could go straight down, I guess, if we wanted it to. It messes things up when things go straight down like that, because what kind of slope is it? What kind of slope goes? Yeah, y equals. Yeah, no, x equals actually. But
Zero.
what kind of slope? What is it?
There's no slope.
No slope. Nose
Solution
slope.
to
No
the
slope.
slope.
No
Yeah.
solution. And so that means that really the slope is a number over 0, and you can't. There's no such thing, right? And then when you're talking about no solution, and then you're talking about getting the derivative of no solution, okay? So that's where things can be a problem. Okay, so but what we're talking about here is not necessarily that it's going straight down. It's just that it's really, really, really steep. That's all. Just really, really, really steep. And in this case, it's really, really, really what? Negative. Oh, that's positive. Sorry about that. Positive. In this case, it's negative. This is just really negative. That's all I'm saying. And then it hits 0, and then it starts to go up. And it's not going up very fast, right? Then it hits 0 again, and it starts to go down. So how many zeros are there? We have 1, 2, 3, 4. So there's 4 humps. 1, 2, 3, 4, 5. There's 5 humps is what I said. And so there's 5 humps. What does that mean? How many, what's the exponent kind of looking like?
Starts out, so it's 6.
Yes. Good job. So it's really x to the 6. So it's really f of x equals x to the 6 of some sort. We're not saying of what sort. It could be 3x to the 6 minus 4x squared minus, you know what I mean? But we're just saying it's got 5 humps, so it's kind of like x to the 6th of some sort, right? Now, in our derivative, what happens? And we talked about this last week. And we talked about how in derivatives, if it started out with a 1, 2, 3, 4, something like that, right? Then it was really x to the 5th, but it ended up frowning, and so it was negative. And then, because the x to the 4th,
It was one more.
wait,
You
1, 2,
start-
3.
you start
That's only
opposite.
3.
You
So this
start
is x to the 4th and it's negative. So x to the 3rd, I'm sorry about that. So x to the 3rd is going to be still negative, but it looks like this, right? So what's this one looking like? It's x to the 6th, and it's ending up frowning. It's even started out frowning, ended up frowning. So it must be negative also. So its derivative is going to be approximately, a negative x to the 5th type of thing. So it's going to look kind of like, well, if it's negative, right? So this next one would be 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay? Did that stop? No. Okay. So, thought I heard something. So, so we have something like this for x to the 5th minus, right? So it's going to look something like this, right? But how? And then that's what we're going to do. We're going to create this from this. We're going to derive this equation from this, or not this equation, this graph from that by looking at the change. So we look at this change right here. What's the change that's going on? Is it positive? Is it negative? Positive. Is it really positive or kind of positive? And we look at the slope. We just kind of look and see, hey, is that like, I don't know, 2 over 1 maybe? So we're kind of looking, just kind of an estimate, that's all. So we're looking over here at what's happening. And over here, what's happening is it's starting out up here, like maybe somewhere around 2-ish. You know, just giving it a unit. We're not giving it a direct, we're just kind of giving it an understanding. Okay? So it's starting out here. And then what's happening? So we're going to put points 2, 3, 4, 5, 6, 7. So now I can see, oh wait, 1, 2, 3, 4, 5, 6, 7. I can do the same thing. I can look at these points, at what's happening, and go, oh, well, this is happening at -1, so about right there, -1, right? And then what's happening at this major point? Where is this major point? And this major point is at 1, and what's happening to it? It's 0. Its slope is 0, right? Its slope is 0. So that's the change that's going on. It's gone from positive to 0. Then what's happening to it? Well, it's becoming negative. Oh, well, that's important to know, so I need to graph that. So it's becoming how negative? Is it this negative or a little less? So this one looks to me like about maybe like a -1-ish, right? So now instead of being up here at -2, right here at, say, 2.5, I'm at -1-ish. Okay? So I'm just piecing the puzzle together. Okay, now here at 2, I'm becoming 0 again. So somewhere it changed. It went from being negative to being 0. See that? So it went from negative to 0. And now what's happening? It's becoming positive. Now, you might want to take 2 slopes and look at how positive it's becoming. And, you know, it's all relative, because this isn't an exact problem. It's just relative. It's, you're looking at it and just kind of go, okay, I'm getting a guesstimation for what's going on. And this looks, I don't know, you want to call it 3 to 1? Maybe, you know, that would be good for me. And it's a little bit steeper than this, right? And this was 2, so why don't we call that 3, right? So, and where is that point? Well, somewhere around here. So let's just call that 1, 2, 3. So 1, 2, 3. It's at about 3. So I'm going to come up here and I'm going to put that dot. Okay, and then I come out to 4, and it's at 0 again. Right? It went all the way up, and then it went all the way back down to here. And not only did it go, but by the time I'm at 4.5, 4.5, it's like way steep. Like, I don't know what you want to call it. Maybe, I don't know, -9 or something. 1, 2, 3, 4, 5, 6. Let's call it 6. Let's just say, but we're showing that it's way negative. It went way negative all of a sudden. So right here, it went all the way, like, I don't know, let's just say it's way down there for some reason. Just way down there, right? It just went way negative. And then, what happened? At 5, it went 0 again.